All right, so in this lesson, we are going to move on to more factoring. All right. So so last lesson was kind of an introduction where we found the greatest common factor, polynomials, and factor them out. All right. So this time, or for this lesson, what we're going to be doing is we're going to be looking at kind of like more complicated polynomials to factor. All right. But to start off with, we're going to do a little bit of review. So we're going to expand and simplify this here, right? These two sets of brackets. Remember, factoring is the opposite. Right? So, anyways, yeah. So let's expand this out. So when we got two sets of brackets, right? We're going to FOIL this out. So that stands for first, outside, inside, last. So there's going to be four terms here. Okay. So x times x is x squared. Outside terms, x times 3 is 3x. Inside terms, we got 4 times x, which is 4x. And then we have 4 times 3, which is 12. And if we collect our like terms, we have x squared, and then 3x plus 4x is 7x plus 12. Okay, so this here is the polynomial with these sets of brackets expanded, right, and simplified. So these are equal. And again, when we're factoring, what we're going to do today is we're going to show you how to go from here back to this way. Okay, so again, that direction is factoring. Okay, so again, factoring is the opposite of expanding and simplifying. All right, so, and again, this factoring concept is very important. Right? It'll keep showing up throughout your whole math career, so it's very important to master this. Right? So we need to master this. All right, so first example here, we're going to factor, and we're going to check by expanding. So notice here that I wrote up the same here. It's x squared plus 7x plus 12. It's the same one here that we got expanded. So essentially, we do know what the answer is. Okay? But now I'm going to show you how to actually get there. All right, so what we want to do here is whenever you have an x squared, right, so there's no number, which implies that it's actually a 1 in front, right? We can use this method. Right? So basically what you want to do is you want to find, so it's kind of like a riddle, right? You want two numbers that multiply to the constant term, in other words, the 12 here, without a variable, without an x. And then we need the same two numbers that multiply to 12 must add to the number in front of the x, which is 7. Right? All right, so in other words, I want two numbers that multiply to positive 12 and add to positive 7. Now, once you do this enough, right, you could probably do it in your head. Now, if you can't really figure this out off the top of your head, like two numbers that multiply 12 add to 7, what you can do is you can list off the factors of the number you're looking to multiply to. So in this case, positive 12. All right. So the factors of 12, we can have 1 times 12, obviously. We have 2 times 6. We also have 3 times 4. And technically, we also have negative 1 times negative 12, negative 2 times negative 6, negative 3 times negative 4. Okay. So I want the two numbers here that multiply to positive 12 and add to positive 7. All right. So since it adds to a positive 7, these two numbers, these three sets, when you add them together, these turn out to be negative numbers, right? So since that's negative 13, negative 8, and negative 7, right? But we want positive 7. So these ones we can automatically just eliminate. Now, if we look here, positive 1 and positive 12 add to 13. 2 plus 6 is 8. 3 plus 4 is the pair that I'm looking for, all right, because this adds to positive 7. All right, and now it's actually fairly simple. What we're going to do here is we're going to write up two sets of brackets. And then write an x in front of both. And basically all I do is I insert the two numbers on this. So that's plus 3, plus 4. And that is it, basically. So x plus 3 times x plus 4 is this x squared plus 7x plus 12 in factored form. All right? And if I scroll it back here, you can see in here, well, I have x plus 4 times x plus 3, but the order that you multiply two numbers or two things doesn't matter. So x plus 4 times x plus 3 is the same as x plus 3 times x plus 4, which is the answer that we got here. All right. Actually, you know what? I'm not even going to do the check expanding part because basically in the review here, that's what we did. We expanded all these brackets, collect our like terms, and we got this question. All right. Cool. So let's try another one. I'm going to factor this and check by expanding. All right. So again, we want two numbers that multiply to the constant term. So let's write m to positive 20 and two numbers that add to negative 9. All right. So again, I'm going to list off the factors of 20, positive 20, and add to negative 9. All right. So since they must multiply to a positive but add to a negative, this means that we're actually going to have two negative numbers. So the reason for that is in order to multiply to a positive, it's either going to be positive times positive or negative times negative, right? We can't have positive and negative or else it'll multiply to a negative number. So once you see that it multiplies to a positive number, you can assume that both signs are the same for both numbers. Now, the other thing is that it adds to a negative 9, right? So obviously, if you add two positive numbers together, you're going to end up with a positive number. You add two negative numbers together, you're going to add to a negative number, right? So this is a good thing to know, right? So in this case, right, if I want two numbers that multiply to a positive but add to a negative, we're dealing with two negative numbers. All right. So what two numbers multiply to 20 and add to 9? Well, I'm just going to quickly list off the factors of 20. But once you do this enough times, you could probably, without writing them out, you could probably just come out with the two numbers in your head. Let's see, there's 1 times 20, there's 2 times 10, and 4 times 5. Okay, so, and again, since I want two negative numbers, dealing with negative sets, right, or negative numbers here. So the one that adds to negative 9 is negative 4, negative 5. So this is going to equal x minus 4 times x minus 5. Okay. Cool. All right, and now the second part here is we can check that our answer is correct by expanding. So I'm going to expand this set of brackets out. So first outside, inside, last, I'm going to FOIL it. What do I got here? I got x squared minus 5x minus 4x plus 20. And if I collect my like terms here, these two middle terms, negative 5x minus 4x is negative 9x plus 20. If I compare that with the original question, x squared minus 9x plus 20, that's what we got. All right. So again, so it's kind of a, when you're doing this factoring, it's kind of like a puzzle, a riddle, where you're trying to find two numbers that multiply to the last term and add to the number in front of the x. All right. Cool. So let's try another one here. This time I want to factor this one here and check by expanding. So again, I'm going to do the same thing. I want two numbers that multiply. Let's use blue ink here. All right, so I want two numbers that multiply to negative 10, add to negative 9. All right, so this time, if the product here is negative, this means that negative means that one number is going to be positive and one number is going to be negative, right? So in order to get two numbers that multiply to a negative number, you have to have opposite signs. Okay, so once you spot that they multiply to a negative, you can safely assume that one's going to be positive, one's going to be negative. Right? So if that's the case, then we want two numbers that add to negative 9. Well, these two numbers have to have a difference of 9. All right, so in this case, what do we got here? Well, 10 times 1, 5 times 2. All right, but if I take negative 10, positive 1, these will work. All right, because if I add these together, I get negative 9. Multiply them together, I get negative 10. All right, so this is going to equal x minus 10 times x plus 1. We're done. Well, not really done, but we're done factoring it. Now what I want to do is I'm just going to quickly check it. So again, let's FOIL this out. Just make sure you get the original question again. But this is going to equal x squared plus 1 times x, which is just x, minus 10x minus 10. And if I collect my like terms, which are these two middle terms here, x minus 10x is negative 9x plus 10. And if I compare it with the original question here, you can see that they're exactly the same. Cool. All right, I believe I got, one more example here. Okay, so for this question here, what you'll notice is that instead of having 1 in front of the x squared, I actually have a 3. So if that's the case, what you want to do here is look for a GCF, greatest common factor first. Right? Well, in this case, we actually do have a GCF, which is 3. Right? 3 goes into 3, 3 goes into 21, 3 goes into 18. So first thing I'm going to do here is, just like that previous lesson, I'm going to factor out the GCF. So I'm going to pull out a 3. So inside the brackets here, I've got x squared. Now, negative 21x divided by 3 is negative 7x. And then 18 divided by 3 is 6. All right, so what I've done here is I pulled out a 3, and as a result, we have this what we call a trinomial, or polynomial with 3 terms, with no longer a number from the x squared. Right? So basically what we're going to try to do now here is we want to factor what's inside the bracket. So in order to do that, again, I want two numbers that multiply to positive 6 and add to negative 7. All right, so what two numbers multiply to positive 6, add to negative 7. So I need 2 negative numbers, right? Because the sign is going to be the same because the product's positive, but they add to negative. So it's negative 6 and negative 1. And so again, these multiply to positive 6, add to negative 7. All right, so as a result, this thing is going to equal. So the 3 I'm going to actually have to keep out in front. But now the brackets here, the x squared minus 7x plus 6, I can break it down into x minus 6 times x minus 1. All right, and there you go. And just to finish this off, all right, I want to also check by expanding. So I'm going to expand out the brackets. So recall that when we multiply, 3 things together, we're just multiplying the first 2 together. Right? So in this case, I got 3x minus 18. Multiply 3 into the brackets. And still got the x minus 1 on the other side. And again, so now I got to FOIL this out. All right, so FOIL it out first, outside, inside, last. So this is going to equal 3x squared outside. So 3x times negative 1 is negative 3x. Inside 1 is negative 18x. And negative 18 times 1 is positive 18. So this is going to equal 3x squared minus 21x plus 18. And let's just make sure that's what we started off with. 3x squared minus 21x plus 18. Cool. All right, guys, so there it is. So yeah, so this takes quite a bit of practice, all right, but this is really this factoring is something that you really need to master in order to be successful, not only in this course but in Math 11 and Math 12.